can be seen from this particular state diagram?
Eliminated states.
Right, we have eliminated redundant states. So that is one particular point. Redundant states. And first of all, let me know the similarities between compound 1, 2, and 3. Now, what is the first difference that you may observe here among 1 to 3? If you compare 1 to 3, compare 1 to 3. Compare state 1 with 2 with 3. And what is the difference that you can notice? Right. So number of states varied. Number of states. Right. Next. What is the difference? Two की keyword is only two keyword. Okay, right. Right. So in state diagram 1 and state diagram 3. But what about state diagram 2? Are there any external outputs? See, so we have marked external outputs here. So this is not marked. What will the answer for this? What will for this? What will the answer for this? What will be the output for this? And what will be the output for this state? Will be the output for this state? For this, what will be the output for this? What about this? What about this? And these are not marked. Can you observe the difference? Difference కనిపిస్తుందా? Can you observe the difference? కనిపిస్తుందా? It's give me a minute. I'll get back to you. If I write it this particular diagram as 1, and if I take this as a 2, and if I consider this as 3, so the differences that I observe are, so in 1, how many states are there? Number of states. So here number of states are 2. How many states are there in the second diagram? 4. What about the third diagram? 4. Right. Now in the first diagram, output function is mentioned. Output function is mentioned. In second diagram, we don't have output function. What about the third? Do we have an output or not? Right. So in third, we have output function. In third, we have output function again. Now what the third? So why third is not preferred? Why third diagram is not preferred? Why third state diagram is not preferred? Right. So here we have redundant states. In third diagram, we have redundant states. What about first diagram? We don't. Do we have any redundant states?
No, sir.
So we don't have any redundant states. So here we don't have any no redundant states. Now what is the problem with the second one? What is the problem with the second one? Are there any redundant states? Second one, the redundant states ఉన్నాయా?
మనం ఇంకా క్యాల్కులేట్ చేయలేదు.
Right. No, why it is not calculated?
ఎక్స్టర్నల్ అవుట్పుట్స్ ఫంక్షన్ లేక సార్ డిఫైన్ చేయలేదు.
Right. Here we don't know about redundant states. We don't know about redundant states. Why it is not known? Redundant states ఎందుకు తెలియదు ఇక్కడ?
External outputs తెలియదు.
Right. No external outputs. So if we don't know the external outputs, can't we measure? I mean, can't we identify redundant states? చేయలేమా? What is the definition of the redundant states? What is the definition of redundant states?
Present state in state same అవ్వాలి సార్.
Right, for one particular state P, for one particular state P, if the next state and outputs are same with that of some x, for x also if you have the same next state and the same output, then P and X are redundant. So if we don't know the outputs, then we cannot say whether it is redundant or not. Can you draw the state diagram for the second, state table for the second one? Second one ki state table draw cheyocha?
No, sir.
Why no? Have you tried? Try chesara? Present state, next state condition. AB is equal to 0, 0, 0, 1, 1, 0 and 1, 1. Then output for 0, 0, 0, 1, 1, 0 and 1, 1. Suppose if my present state is 0, 0, sorry, G naught. And whenever AB is equal to 0, 0, what is my next state? Hello.
వాళ్ళ కొడుకుని
Please mute your mic.
ఆడుకోలేదా
Please mute your mics. Someone is supposed to mute your mics. Right. Hello. If G naught is the present state and if 0, 0 is the input, what will be the next state?
Not
We are discussing regarding this. Right, G naught. If G naught is a present state and if 0, 1 is the input, what will be the next state?
G1.
G1.
G1, right? For 1, 0, what will be the next state?
G1.
G1.
For 1, 1, what is the next state?
H naught.
Right. Okay. Right, now tell me for G1, what will be the next state for 0, 0 condition?
G0.
G naught, right? For 0, 1 condition?
G1.
G1.
G1. So here also it is G1 and here also it is H naught. Right? For H naught, what will be the next state for 0, 0? G1, G1.
G1.
So for Z1 and 1, 0? We get the same H naught. Right. For 1, 1, what will be the next state?
H1.
Right, perfect. Right. Present state is H1. If 0, 0 is the AB value, what will be the next state condition?
G1.
G1. What will be the 0, 1? The next state for 0, 1 input?
H naught.
H0.
For 1, 0?
H0.
H
For 1,
naught.
1? For
H1.
1, right, 1, 1,
H1.
right. Now tell me what will be the output for this 0, 0 condition if G naught is input. So not defined. So we don't know these values. These are not known. Right. Now observe the state diagram. Observe the condition of G naught. Now here you can observe. All the lines which are coming towards the G naught. How many lines are coming towards G naught? This is one line. and this is another line. Only two lines or any other lines towards G naught? How many lines are coming towards G naught? How many lines are coming towards G naught? This is one particular line.
Two, sir.
Only two lines, right? Right, two lines. Now, can you tell me what are the outputs of those two lines? The lines which are coming towards G naught. This is 0, 0 by 0, and another line is this. What is the output of this line?
0.
0, right? Perfect. G1. Let this be H0 and this be H1, right? Now, what are the lines that are coming towards G1? So this is one line. What are the outputs of these lines? 0, 1 by 1, 1, 0 by 1. And what about this line? 0, 1 by 1, 1, 0 by 1. Any other lines coming towards the G1? Right? From H0 and H1. This is again 0, 0 by 1. And this is again, what is the output of this? What is the output of this line, which is coming from H0?
0, 0 by 1, sir.
Right, 0, 0 by 1. Right, now identify the lines which are coming towards H0. What are the lines that are coming towards H0? This is one line whose output is 1, 1 by 0. This is another line whose output is 0, 1 by 0, 1, 0 by 0, and this one. This is, what is this? 0, 1 by 0 and 1, 0 by 0. Any other lines pending with H0?
From G1, sir.
From G1, right, okay. And this is again 1, 1 by 0, 0, right? Now towards H1, what are the lines which are coming towards H1? This is one particular line which is 1, 1 by 1, and this is another line which is 1 by 1 by 1. Now, see this. This is 0, and this is also 0. This is 1, and this is 1. This is 1 here, and this is also 1, and this is also 1, and this is also 1. This is 0, this is 0, this is 0, and this is 0, and these are also zeros. This is 1, and this is 1. Is it visible for you people?
Yes, sir.
Is it visible for you? Try to understand, try to focus on this. Right. So the lines which are coming towards the G0, what are the outputs for the lines which are coming towards the 0?
0.
G0. The line 0, right? So output is 0. Towards the G1,
1, sir.
1.
1. Towards H0,
0, sir.
0.
towards H1,
Ones.
H1, right. Can anyone make a conclusion from this? What is the difference between diagram 1 and diagram 2? What we have done? Diagram 1 ki diagram 2 ke, sorry, diagram 1 ki 3 changes हम. Can anyone tell me the difference by seeing this? What is the diagram between the 1 and 3? 1 ki 3 ki
Three different external outputs.
right? What we have done is we have split. We have made a split of states. Splitting of states such that G is split into G0 and G1. H is split into H0 and H1. Right. And after that, after splitting and after redrawing with the help of this, what is our observation? Outputs if next state is equal to G0 are 0. Here outputs if next state is equal to G. And what are the outputs if next state is equal to G1?
One, sir.
Next
One,
state is
sir.
equal to G1. You need to understand this. Don't get confused. Next state G0 ki vaste output antunnam, not from G0. The students who are coming from their homes to campus. This is your home and this is your campus. Right. So, right, if we consider the home ankonde. So if you are coming towards your home, వచ్చారు అనుకోండి, or else right, this is RGKT and this is your home. So if you are coming towards your home, your energy levels are high, which is equal to 1. And if you are coming towards RGKT, campus వస్తున్నారు అనుకోండి, your energy levels are low, 0. Towards that state, G0 కి towards G0 వస్తే అవుట్పుట్ అనేది 0 అంటున్నాం, not from G0. Is it clear? If next state is equal to G0, if next state is equal to G0, outputs are 0. If next state is equal to G1, outputs are 1. And similarly, so here outputs if next state is H0, what are the outputs?
Zeros.
Right.
0.
So we did not bother about the previous states. Say next state అనేది H1 అని చెప్పేసి అంటున్నాం. See here, so we are saying that whenever you are going to your home, whenever the next state is equal to home, your energy levels are 1. The previous state it need not unknown. Whether unknown, it can be either RGKT or it can be any other place, any other workplace, or it may be your relatives, or it may be something else, NCC tour, etc. Previous state can be anything. So previous state గురించి మీరు వరీ అవ్వాల్సిన అవసరం లేదు సార్. ప్రీవియస్ స్టేట్ ఎక్కడి నుంచి రావాలి? ప్రీవియస్ స్టేట్ we need not consider the previous state. We are supposed to consider only the next state. Next state depending upon the next state, these values will be considered. So here, whenever my next state is H1, outputs if next state is equal to H1 what will be my output? Is equal to 1, right? So this is what that is learned from the mealy state diagram. From where it is learned? By including, right, mealy state diagram, by including additional states to diagram 1. By including additional states to diagram 1, so it resulted in diagram 3. Right? And we have discussed regarding the diagram 1 and diagram 3, which is or differences అని చేసాం. Now what about the diagram 2 which is available? What can be done for this? దీన్ని ఏం చేయొచ్చు? State diagram 3, is it useful or not useful? State diagram 3. State diagram 3, is it useful or not? We have 3 state diagrams. State diagram 3, is it useful or not useful? Hello. 3 useful. Hello. Yeah, that's the reason I asked you to go through the previous notes. Already చెప్పాను మీకు. You are supposed to go through the notes and చెప్పేసి. Is the state diagram useful or not?
No, sir.
No, why no? Why? Right, we have redundant states. That is what we have discussed. We have redundant states. So this is not useful. Diagram 3 is not useful. Diagram 1 is. Now the concept which we have understood in diagram 3 is useful. Now what is the concept that we have understood in diagram 3? So the next states, the states which are coming towards a G naught, output is 0. So towards a H naught it is 0. Towards G1 it is 1. Towards H1 it is again 1. So such concepts. So how can we fix states? Right. Also from state diagram 1, and also from state diagram 3, what is that we have learned regarding the output? Output Z is a function of, it is a function of, Z is a function of what?
Q not A B C.
Q? Comma Q, right.
QAB.
So Q comma A comma B. Now which is nothing but as a function of Q is nothing but the state, present state, comma present inputs. So that is output depends upon present state plus present inputs. It depends upon both the present state and the present inputs, right? So this is what we have understood in the state diagram 1 and state diagram 3. Now the state diagram 2, if you analyze, so applying the concept of state diagram 3 to state diagram 2. Right. This is G naught, H naught, G1 and H1. Now please tell me the values here. What are the values for this? For G0. State diagram 2. State diagram 2. 0, 0. Here we have 0, 0. What about this?
0, 1, 1, 0.
Right, this is 0, 1, comma 1, 0. And what about this?
0, 1, 1, 0.
0, 1 and 1, 0, right. Now what about this?
0, 0.
0, 0, right. What about this line?
1, 1, 4.
1, 1, right. And what about this line?
0, 1, 1, 0.
0, 1, comma 1, 0, right. What about this?
1, 1.
1, 1, right. And we have lines from this also. What about this? G1 to H.
1, 1, 4.
1, 1. What about this?
0, 0, 4.
0, 0. What about this line?
0, 1, 1, 0.
This is 0, 1, 1, 0. Right. And what about this?
1, 1, 4.
And do we have a line from G1 to H1?
H1 to G1.
Right, H1 to G1. Right. What about this?
0, 0.
And do we have a line from H0 to G0?
No, sir.
No. Right. Right. We don't have any line. Right. Now, what we do is concept of 3 and 2. Now, with that, I'll say that so the output in this state is 0 always. Output in this state is 1 always. Output in H0
Zero.
is 0 always. And H1 is 1 always. The denominator here represents the output. Denominator represents the output. This indicates G0 state with 0 output. And this indicates H0 state with 0 output. And this indicates G1 state with 1 output. And this is going to indicate the H1 state with 1 output, 1 as output. So if we are in G0 state, right, I'll draw the truth table for this now, state transition table. present state, next state, and output values. Here we have AB value as 0, 0, 0, 1, 1, 0, and 1, 1. And here the AB values are 0, 0, 0, 1, 1, 0, and 1, 1. Right, how many can hear my voice, and how many clarity in voice and clarity in video with screen? Section 5, 6. How many are having clarity in audio, clarity in video? Is there any lag? Right, can you send a message? No lag, everything is okay, clear. Right. Okay, we shall proceed. Are you following? Is it okay?
Yes, sir.
Yes, sir.
Right. Present state is G naught. Present state is G naught from this particular diagram. If 0, 0 is my input, what is the next state? Present state G naught. If 0, 0 is my input, what is the next state? Right, the same G naught value, G naught itself. If a 0, 1, what is my next state?
G1.
If 1, 0, what is my next state?
G1.
Z1.
G1. If 1, 1, what is my next state?
H0.
H naught.
H not, sir.
Right. Now, understand this clearly. Whenever the state is G naught, output is 0. Output is 0. Now you forget everything. So whenever
No, sir.
which
Sir, అది
state
incoming.
state
సార్ నెక్స్ట్ స్టేట్ జీ నాట్ ఉన్నప్పుడు 0 సార్. నెక్స్ట్ స్టేట్ G1 ఉన్నప్పుడు 1 సార్.
no don't get confused here. మనం ఆ కాన్సెప్ట్ ని మొత్తం కూడా అప్లై చేయట్లేదు. That we have understood in what kind of diagrams whenever so the state is interlinked with this particular input values. Whenever the state is interlinked with this particular input values, మనం ఏమన్నామంటే so next state ఎక్కడికి వెళ్తున్నాం అది ఇంపార్టెంట్ అన్నాం. whether you are going to RGKT or whether you are going to home, that is important. So that happens whenever you are writing both the things రెండు రాసేటప్పుడు. So the concept which we are expecting here is G naught అనేది ఓన్లీ అవుట్పుట్ 0 ఉండొచ్చు, G naught అనేది ఓన్లీ అవుట్పుట్ 1 ఉండొచ్చు, ఆర్ G1 దగ్గర ఓన్లీ అవుట్పుట్ one particular output ఉండొచ్చు. ఓన్లీ దట్ particular concept. We are not taking that concept as it is. ఇది మొత్తం as it is తీసుకోవట్లేదు. ఓన్లీ మనం స్టేట్ తో బైండ్ చేస్తాం in this. The only logic I want you to understand from that is we can attach one particular output to one particular state. That's it. అంతకుమించి ఎక్కువ కన్ఫ్యూజ్ అవ్వకండి. one particular output to one particular state. So G naught కి నేను మొత్తం కూడా ఇంకా 0 అని ఫిక్స్ చేసేస్తాను. You will see this what will happen. G naught కి మొత్తం 0 అయిపోతుంది ఇంకా. Right. G1. You will be getting the same states, and for this I will be fixing the output as 1 గా ఫిక్స్ చేస్తాం. H naught, can you tell me the H naught values? You'll get clarity while doing this. H naught, but G1, H naught,
H not,
H naught,
H not,
H1. So for this again it is 0. But for H1 you will be getting the same states. 1, 1, 1, 1. Right, now tell me, are there any redundant states in this? Are there any redundant states?
No.
No, sir.
Are there any redundant states? Why no? Why yes?
Next state not equals to output.
Right. No redundant states here. So why? Because G0 and G1 are having G0 and G1 are having same next states, but
not same.
different outputs. Andena?
Yes, sir.
Same next state, but different outputs. From the state diagram, same states untai. Same next states are same. For G0 and G1, for H0 and H1. So same states, but only outputs are different, and hence, so we are not having any redundant states. So now, can we go for state minimization here? Is
No, sir.
state minimization possible?
No, sir.
State minimization possible? No. So state minimization is not possible. State minimization is not possible. Is it state redundancy unda? About redundancy, is it clear in this state transition table?
Yes, sir.
Redundancy,
Yes,
same next state only, same output. Rendu match avali, then only we call those states as redundant states. Same
Redundant.
next state and same output. So same next states unnai. So G0, so G0, G1, G1, H0, G0, G1, G1, H0. Same next states, but different outputs here. This is 0, this is 1. Different output. It's different outputs. When you see this, the last day class, see here, we got, see this is what we got. Same next state as well as same outputs 0, 0, 1, 1, 0, 1, 1, 0, 0. Same outputs we have obtained. But today it is not like that. So we got different set of outputs here. Right. Now we need to see, will there be any advantage? Now what is the advantage in this? So that we'll see here. Proceed further. Can you realize this particular state transition table with the flip-flops? Can you do it? Can you realize this with the help of flip-flops? How many flip-flops are required here?
Two,
Two,
sir.
sir.
Two, sir.
How many states are
Total
present here? How many states are
four.
present here? Right, 4
Four,
states.
4 states.
Right, further implementation. First of all, we need to go for state assignment. State assignment. State assignment. So how many states are there? Number of states are 4. What are they? G0, G1, H0 and H1. How many bits are required whenever there are 4 states?
2 bits.
2 bits, sir.
So number of bits required is equal to 2 bits. Right, now the state assignment is like this. G0 will be assigned with a 0, 0. You may assign 1, 1 also, there won't be any issue. G1 will be assigned with a 0, 1. H0 is given the value of 1, 0. H1 is given the value of 1, 1, and this is called as state assignment. State assignment depends upon state assignment depends number of bits, right? State assignment depends upon number of bits. Number of bits, right? Now after this, present state. Let us represent present state with the help of Q1, Q0. And next, what we are supposed to write down next? Present input is to be written, which is AB. Next, we can write down here. Next, the state can be written, which is a Q1 plus and the Q0 plus. Output can be written here, which is Z. Now flip-flops. How many flip-flops are required? 2 flip-flops. D1 and the D0. Present states, present input values, next state values, output values, and flip-flop inputs. Right. How many combinations will be there here?
16.
16.
సార్ D1 D0 ఏం మారవు కదా సార్ ఎక్స్ప్రెషన్స్
అంటే
ఎస్టర్డే ఎక్స్ప్రెషన్స్ ఉంటాయి కదా సార్ D1 D0
we don't
ఓన్లీ జస్ట్
D1
అవుట్పుట్
D0.
చేంజ్
Yes,
అవుతుంది
D1 D0 will not change. D1 D0 will not change. This is 0 1 0 1 and 0 1. Right, tell me what are the next states here? What is the next state here?
జీరో జీరో
Okay, next.
0
0 1. Next.
0
Okay, next.
1 0
1 0. So here will be same. 0 0 0 1 0 1 1 0. Okay. Next here.
0
0 1. Next.
1 0
1 0. Next.
1 0
1 0. Next.
1 1
Okay, perfect. 0 1 here, 1 0 here, 1 0 here, and 1 1 here. Right. So whenever it is G0, outputs are zeros, and whenever it is G1, outputs are ones. Whenever it is H0, outputs are zeros. Whenever it is H1, outputs are ones. Right. D1, D0, D1 will be equal to Q1 plus. If we compare these two, we'll be getting the value of this. And if we compare Q0 with Q0 plus, we are going to get the value of D0 plus. D0 value. Right, so this is 0, 0, 0, 1, 0, 1 and 1, 0. Right here also this is 0, 0, 0, 1, 0, 1, 1, 0. This is 0, 1, 1, 0, 1, 0 and 1, 1. This will be 0, 1, 1, 0, 1, 0 and 1, 1. Right. Okay, can someone tell me what will be the expression for Z? What will be the expression for Z? Right, we need not use K-maps also. Q0, 0, 0, 0, and this is 1. Right. So direct Z is equal to Q0. Z, which is an input of. Can someone tell me the minterms for Z first of all? What are the inputs? Q1, Q0, A and B. These are the inputs. What are the minterms for Z? Sigma M of. What are the minterms for Z?
4, 5, 7, 6, 12, 13, 14.
4, 5, 6, 7, 12, 13, 14 and 15. Right, from this is equal to Q0. Right, that is equal to Q0. Okay. Now D1, which is a function of Q1, Q0, A comma B, this is equal to sigma M of. What are the minterms for D1? What are the minterms for D1? What are the minterms for D1?
3, 7,
3, 7,
9, 10, 11, 12, 13,
just a
sorry,
minute.
13, 14, 15.
3, 7,
9, 10, 11,
9, 10,
10,
11,
11,
13, 14, 15.
13, 14, 15.
13, 14 and 15. Now what is the expression for this? Using K-maps. D0 of Q1, Q0, A comma B. Now what are the minterms in this? What are the minterms in this? D0. 1, 2, 5, 6,
8, 11, 12, 15.
8,
11,
11,
8,
12, 15.
8, 11, 12, 15. 8, 11, 12 and 15. Right, perfect. What is the expression for D1 and what is the expression for D0? Use 4 variable K-maps.
So D1 equal to AB plus Q1 of A plus B.
AB plus
Q1 of A plus B.
P1 of A plus B. So this will also be equal to AB plus Q1 into A XOR B. You please check it once, rearrange the terms, you will be getting that. What about D0? What about D0?
Q1 XOR A XOR
Q1 XOR with A XOR with B. Q1 XOR with A XOR with B. Right. So 2D flip-flops are to be taken here. Let this be flip-flop D0, Q0, Q0 bar, a positive edge declared D flip-flop. And let this be another flip-flop. D1, Q1 and Q1 bar. So these are going to have the same clock signal. Right, what is D0? D0 is equal to Q1 XOR A XOR B. Q1 XOR A XOR B. A and B. So what is this? So this is nothing but a full, if you take a full adder block, if you take a full adder block, if this is my full adder block, so one of the input is A, another input is B. What is another input for this?
Q1.
Right, to Q1. So Q1 is available here. So full adder is going to generate sum as well as carry. Sum as well as carry. Sum is equal to, no, what is this? This is nothing but a Q1. Sum is equal to Q1 XOR A XOR B. Now what is carry is AB plus Q1 into A XOR B. This is to be given for where this is to be given. Then केवल
Carry D1s.
D0, D0, D0.
Sums.
Sum, sir. Sum is given to D0.
Right, right.
Sum.
Sum is to be given for this part, and the carry is to be given for
D1.
this is to be given for this D1. All right. And finally, we take outputs. What is the value of a Z? Z is
Q.
Q naught.
so
Q naught.
Z is equal to Q naught. right? From there we can take, or from here. So this is Z, which is equal to Q1 XOR with A XOR with a B. Now what about the carry? AB plus Q1 into A XOR B. So carry can be taken here. Now Z is depending upon Z is depending upon
D naught.
can I say that Z
Q1
is
economics.
so Z is equal to Q naught kada ikkada?
Yes, sir.
That is what we have written, right? What
Yes,
is
sir.
Z? What is Z? Z is equal to, from expressions we got, Z is equal to Q naught, and this is my Z value. This is my Z value, and carry is equal to AB plus Q1 into A XOR B. So from here, carry can be taken. So this is my carry value. Now, what is the basic difference between the problem which is taken earlier and the problem which is taken now? Yesterday's solution and today's solution.
Outputs Z.
So Z, today Z is equal to Q naught, where Q naught is nothing but a state. Yesterday Z is equal to, what is Z value? In yesterday's class, what is the value of the Z?
Q1 XOR A XOR B.
Right. So Q XOR A XOR B. Q XOR A XOR B. So here this is a function of both state plus inputs, or clearly Z is a function of present state comma present inputs. Now here Z is a function of what? Present state only. Z is a function of a present state only. Is it clear? And this we have proved in state diagram and proved through circuit diagram also. Will you agree with this? This is also proved in state diagram and proved through circuit diagram. Will you agree with this? Hello? See, if you see this state diagram, output, is it depending upon input? Input may depend outunda, state may depend outunda.
State dependence.
State dependent. What are the inputs which are present across G0 మీద ఏం inputs ఉన్నాయి? This is 0 0 is present, and here 0 0 is present, right? Okay, ఇక్కడ only two, only same state ఉంది. Now H0, across H0, see what are the inputs that are present across H0. H0 దగ్గర ఏమున్నాయి? So this is 0 1, this is 1 0, this is 1 1. So different inputs are present, but you're saying that whenever I'm in H naught, my state is 0. At next state adanте kaadu. If I am present at H naught, my state value is 0. If I am present at G naught, my state value is 0. If I am present at G1, my state value is 1. If I am present at H1, my state value is 1. So if I am present at home, my state value is 1. If I am present at RGKT, my energy levels are 0. So incoming consider cheyatledu and outgoing consider cheyatledu. Whether it is incoming or whether it is outgoing, it doesn't matter. If you have reached home, if you are in home, your energy levels will be high, irrespective of entry or exit. Adanతా కాదు. If your present state is home, so your present location is home, your energy levels are 1. Your present location is RGKT, your energy levels are 0. That's it. Only present location ఇంకా అది ఇన్కమింగ్ అవుట్ గోయింగ్ అదంతా వదిలేసేయండి. ఓన్లీ present location dependent, irrespective of input conditions. 0 1 1 0 1 1 ఏవైనా ఉండొచ్చు input conditions. Irrespective of those, depending upon your current location, your outputs are fixed. Outputs అనేవి ఫిక్స్ చేయాలి. So that we have defined here, and the same is projected here also. Now here, say this, you cannot find any redundant state here. I mean, the redundant state కనిపిస్తుందా? Yesterday we have observed redundant states, but today, can you find any redundant state? So if you remove Q1, what will happen? Q1 and తీసేస్తే ఏమవుతుంది? Hello.
Output rise.
Now we cannot get carry of full adder. Suppose if you remove Q0, then what will happen? You won't get Z value. So no redundant states. But in state diagram 3 circuit, you got that. So this is related to state diagram 1, and this is related to state diagram 2, state diagram 1 and state diagram 2. So state diagram 3 will be ignored. State diagram 3 will not be considered. And now this is called as circuits which are of this kind. These are called as Moore state machines. And circuits which are of this kind are called as mealy state machines. And this is, what is this? Is this a mealy state machine or Moore state machine? This is Moore state machine. What about this state diagram? This is also connected with Moore. So, and this is connected with the mealy. This is mealy state diagram. And this is also mealy state diagram. Whereas this is Moore state diagram. Is it clear?
Clear.
Is it clear for everyone? So just one particular definition. I told this, whenever output maybe Z or Y or anything, output is a function of present state and the present input, then such circuits are called as mealy state machines. mealy state machines. And whenever output is a function of only present state, then such circuits are called as more state machines. More state machines. See, output is not a next state here. ఇది present output, ఇది next state గురించి మాట్లాడలేదు, output గురించి మాట్లాడుతున్నాం. Output and state are different. Is it clear? Only to understand, to make you understand this particular definition, I have taken the last class and the today's class. This is important. This is important. So these questions will be asked on this in MTech gate interviews. And also for core companies. Is it clear?
Clear.
Is it clear? So if I would have taught only this definitions, only 2 lines meeku cheppunte. So the first immediate question you might have asked is, now how output depends only on present state, only on state. How is it possible? So this will be the question which will be coming, which will be striking on our minds immediately. But we have proved that. We have proved by taking an example. Now, what is the main disadvantage in more state machines? What will happen whenever we are moving from mealy state machine to more state machine? ఏమవుతుంది? What is the main disadvantage? The redundant states will not be there. Redundant states will eliminate just some. In more state machines, there won't be redundant states. Right? What is the main disadvantage? What is the main disadvantage? What is the main disadvantage between diagram 1 and diagram 2? Diagram 1 ki 2 main disadvantage enti? Or main change enti? What is the main
Two
change?
states ki same output ఉంది.
And the number of states ఏమవుతున్నాయి?
Increase అవుతుంది. Same output.
Number of states will increase. Definitely number of states will increase. Definitely number of states will increase. Whenever we are moving from mealy state to more state, number of states will increase. Why? Because in more state machine we are fixing one particular state to one particular output. Isn't it?
Yes, sir.
We are fixing one particular state with one particular output in more machine. So whenever we are moving from mealy state machine to more machine, definitely the number of states are going to increase. 90% the number of states will increase. 90% the number of states will increase. ఎందుకంటే ఓన్లీ వన్ స్టేట్కి వన్ అవుట్పుట్ ఉండాలి అని చెప్పేసి అంటున్నాం కాబట్టి మోర్ స్టేట్ మిషన్స్కి నెంబర్ ఆఫ్ స్టేట్స్ ఇంక్రీజ్ అవుతాయి. That thing. So I'll do problems on this. But the main thing is you need to understand the difference between the mealy machine and more machine. Yes, tell me.
Then why should move to more, sir? అంటే మీలీలోనే
లేదు, ఓన్లీ స్టేట్స్ మీద మాత్రమే నాకు అవుట్పుట్ డిఫైన్ అవ్వాలి అని అప్లికేషన్ ఏమైనా ఉందనుకోండి, ఓన్లీ స్టేట్స్ మీద, ఓన్లీ నాకు కౌంటర్ అవుట్పుట్స్ మీద మాత్రం బేస్ అయ్యి అవుట్పుట్ రావాలి. ఓన్లీ బేస్డ్ అపాన్ కౌంటర్ అవుట్పుట్స్. కౌంటర్ని బేస్ చేసుకొని అవుట్పుట్ రావాలి అని చెప్పేసి అనుకుంటే దెన్ ఫర్ దట్ అప్లికేషన్ యూ ఆర్ సపోజ్ టు గో ఫర్ మోర్ స్టేట్ మెషిన్స్. కాంబినేషన్లో అవుట్పుట్ వద్దు, నాకు ఓన్లీ కౌంటర్ అవుట్పుట్ మీద మాత్రమే అవుట్పుట్ రావాలి అని చెప్పేసి స్పెసిఫిక్గా ఉంటే దెన్ యూ ఆర్ సపోజ్ టు గో టు మోర్ మెషిన్. So, is it clear for everyone?
Clear, sir.
Right. See, these are the names. Mealy and more are the names. Then I don't remember this. In 1955, 1956, we got these concepts. Mealy machine and more machine. Can you say this?
Yes, sir.
You need not remember these names. This is not essential. So first mealy machines came into existence, and after that, in a couple of years, more machine came into existence. Then I got a good PDF also, PPT also. I'll be sharing this with you. You please go through this once. Serial ladder. So there are some other problems in this. You please go through mealy machine and more machine. And before that, so once again, I'm requesting you to go through the today's and yesterday's PDF. So it is compulsory for everyone. If you want to understand the next concept, you are supposed to go through the today's and yesterday's PDF. Then only you will understand what is happening with mealy machine and more machine, what are redundant states, and how state minimization is being done. How state minimization is being done. So at present we are covering the topics of, these are the topics that we are covering now. Mealy machines, more machines. Next, mealy machines and more model for serial adder. Now, tomorrow we will discuss this. Tomorrow, in the sense, after next week, conversion of mealy machines to more machines and vice versa. This is to be discussed. This is done, and this is done, and this is done. So this is not done. Sequence detectors will do it. Then after that, even an odd parity will do it. So we are going to finish this topic. So I have explained you this thing. You have also done multiplexes, decoders, multi-bit adders, subtractors. Will do some problems also if required. So timing control is just a waveform analysis. blocking and non-blocking assignments. With a couple of examples, I will explain you this topic. The combinational synthesis is nothing but, again, all these things: code converters, multiplexers, decoders, any combinational function. So the important thing in this unit 3 is to understand the basic difference between the mealy machine and the Moore machine. So the basic definition in this sense, not only this one. In addition to this, you need to understand the concept also. Is it clear?
Clear.
Right. So we are increasing the states. Then by increasing the states, we are getting the output, required output. Mealy machines when just known. So in mealy machines, the output is dependent upon both input as well as the state. And by increasing the number of states, so we are making the output to be dependent upon state. So that is more state machine. Right. When do you have exam? DLD exam?
Tuesdays.
Tuesday. At what slot? Time?
Morning 8:30.
8:30 to
10:30.
2 hours. Huh? Okay. Anyone who is yet to submit assignment, DLD assignment? Is it done by everyone?
ఇంకా అందరు సబ్మిట్ చేయలేదు.
చేయలేదు, ఒకసారి నోట్ డౌన్ చేసుకోండి ఎవరో చేయలేదు ఇంకా. వెన్ ఈజ్ ఆ డెడ్ లైన్?
ఈ రోజు అని చెప్పారు సార్, టైం చెప్పలేదు.
ఓకే, ఈరోజు నైట్ వరకు ఉండండి. రేపు మార్నింగ్ నాకు పంపించండి లిస్ట్ ఆఫ్ ద స్టూడెంట్స్ who did not submit assignment, and
Okay,
convey the information that their papers will not be evaluated mid examination. If they won't submit the assignment by today, I won't be evaluating their papers, and I won't be allowing them for the lab sessions also when you come to the campus. Right. Thank you.